Hello students, I am Dr. Praveen Jain. I am uh, teaching you this problematic soil and their management in this semester, and today I am going to discuss about the irrigation water and its quality. This is important from this point of view that sometimes your soils are healthy and they don't have any problem, but we if we irrigate them with some problematic water or a water of high salt concentrations and poor quality water, and then what happens that this water get evaporated with time, but the salts remains in the soil and then they make the soils unhealthy and problematic. So we will be having discussion on this in this top presentation. Waters are not pure and may contain some soluble salts. In arid and semi-arid regions, successful crop production without supplemental irrigation is not possible. So irrigation water is usually drawn from surface or groundwater sources, which typically contain salts in the range of 200 to 2000 ppm, and irrigation water contains 10 to 100 times more salts than rainwater. So this is the major issue you can say, particularly when we are irrigating the crops with in the arid and semi-arid regions. The suitability criteria for irrigation is the water which is you are going to apply for irrigation depends upon several factors such as water quality, soil type, plant characteristics, irrigation methods, drainage, climate, and local conditions. The integrated effect of these factors on the suitability of irrigation water can be expressed by the relationship as SI, or you can say the suitability criteria, or suitable irrigation, you can say, is the summation of QSPCD. Now, what is this? We are going to discuss. Q is the quality of irrigation water, that is total salt concentrations, relative proportion of cations, etc. So that is the quantity, quality, the total soil concentrations in the salts, in the water, which is normally the cations. The S is soil type, the texture, structure, permeability, fertility, calcium carbonate content, types of clay minerals, and initial levels of salinity and alkalinity before irrigation. So S is the factor which is reflecting these things, that is the type of soil, texture, structure, permeability, fertility, calcium, and all these things. The P is the salt tolerance, characteristics of crop to be grown and its variety and growth stages. The C reflects the climate, the total rainfall, its distribution, evaporation characteristics. And the D is the drainage conditions, depth of water table, nature, soil profile presence, hard pan, underlying concentration, and all. If somebody is walking somewhere on the road, please just uh, mute yourself. Criteria is the total salt concentrations, the sodium absorption ratio, the residual sodium carbonate and bicarbonate ion concentrations, and boron contents. You must be remembering that while I was discussing with you about. Again, I'm starting up with the things. The soluble total salt concentrations, the sodium absorption ratio, residual sodium carbonate, bicarbonate ions and concentration, and boron contents. We have the total salt concentrations. The water used for irrigation can vary greatly in quality depending upon the types and quality of dissolved salts. The salts present in the irrigation water is relatively small, but significant amounts are there. So what happens? The idea is that when you are irrigating a soil with the water, what is happening that these soluble salts also get to the soil, and once the water which is either been lost go through transpiration or evapotranspirational things, as जो soil है, जो open surface है, वहां से soil जो है, जो water है, वो evaporate करेगा और plants जो हैं water को transpire करेंगे। तो with time and जो sunlight है उसकी वजह से, तो वह क्या होगा कि पानी सारा उड़ जाएगा in the form of vapors, and remaining is the salts, and their salts they come in the soil, and they are increasing the soil concentration of salts which are not required in the soil, and hence increasing the cation exchange and the electrical conductivity of the area. Or, like function of temperature, type of concentration of various ions. So this is calculated as C1, C2, C3, C4, and C5. The C1 is low, that is below 250, and the millimoles is measured as millimoles and micromoles, and then high is more than 5,000. Just like your pH meter, there is a electric conductivity meters in the laboratories, and you can just use it. There must be some practicals in your soil courses which you will be doing on these things whenever you will be in the campus. Now, sodicity is the term given to the amount of sodium held in the soil. The sodium is a cation that is held loosely on clay particles in soil. It is one of the many types of cations that are bound to clay particles. Now, what is there? As you know that sodium is Na plus, the single, you can say, monovalent ion, and it is a cation actually, and this is get fixed up on the colloidal surfaces, and hence it is replacing lots of other ions and just get there, and it is in the form is whenever there is sodium concentration in water, again this is coming up in the soil and increasing the concentration, and this is come up as a sodium absorption ratio. This is the SAR is the water indicates the relative proportion of sodium to other cations. Now, how much sodium is there versus the other cations? So this is giving you a kind of sodium absorption ratio. The ion concentration expressed as milliequivalents per liter. Increase in SAR of water increase the exchangeable sodium percentage, the ESP. This is called the exchangeable sodium percentage. There is a linear relationship between SAR and ESP of the soil. So what is we mean by ESP? That the linear relation. This is the direct relation. Whenever there is an increase in SAR, there is an increase in ESP. So this is the increase. There is a direct relation. So this is like this. So there is a United States Salinity Laboratory. The USS staff introduced the concept of sodium absorption ratio to predict sodium hazards. So this is the term given by USSL. This may come up in any MCQ, maybe that from where this SAR word has come. So you can, I hope you can answer. The sodium classes or sodicity classes of water is like low sodium hazards, the low sodium water, there is little or no hazards. Then medium sodium hazards, the SAR is given as 10 to 18, high is 18 to 26, and very high is again more than 26. So ultimately these all are a reason that how you can predict and how you can calculate the sodium effect on the soil's poor health. So harmful effect of sodic water includes destruction of soil structure, crust formation, poor seedling emergence, reduction in availability of nitrogen, zinc, and iron due to increased soil pH, sodium toxicity, and toxicity of boron and molybdenum due to their excessive solubility. Now, what happens whenever there is a जब सोडियम जो है इस इरिगेशन वाटर में होगा, ये सॉइल में चला जाएगा, वहां से इट विल डिस्टर्ब द सॉइल स्ट्रक्चर, सॉइल के स्ट्रक्चर को खराब करेगा, इसकी when this water get evaporated, the जो salts हैं वो surface पे आ जाएंगे. आपने note किया होगा बहुत बार जो soil है उसके ऊपर एक white color की layer जम जाती है जैसे हल्की सी snow है. That is due to this sodium crust. And then ये जो crust है it makes the soils typically salty, and जो भी seedling emerge करता है it comes in contact and the seedling may die. And then again this is disturbing the pH also, and when there is a disturbance in pH, this is always disturbing the availability of ions, the other essential ions, and their disturbance happens because the pH gets fluctuated. And once the pH, because all I have just, if you remember, I have given you in one of the lecture that the neutrality, the soil neutrality or the neutral level is that where the nutrients are available in adequate amounts, but at the lower acidic or alkalic situations, they get either toxic or either become unavailable. So this is something regarding the availability and all that. Then boron content. So the boron content also has an important role because boron is also under the essential nutrients, and its concentration varies with this, the salts. So though boron is essential micronutrient for plant growth, its presence in excess in irrigation water affects metabolic activities of plant. For normal crop growth, the safe limit of boron contents is S100. Now, I hope do you know you must be knowing that the boron plays a very important role in the crops like cauliflowers. Or different cool crops you can say, and they have and if there is a deficiency the typical symptoms comes, and then though it is required in a very less amount, but this deficiency plays a very important role. So this is about the boron things, which is also needed, you can say, in the through irrigation water and all. Then chlorides. The chlorides occurrence of chloride ion in irrigation water increases with increase in EC and sodium ions. Therefore, these ions are most dominant in very high salinity soils. Now you know that sodium chloride, we say that, and then sodium and chloride is go together. And unlike sodium ions, the chloride ions neither affect on the physical properties of the soil nor are absorbed by the soil. Therefore, it is generally not been included in modern classification systems. But however, it is used as a factor in some regional water classifications. So normally we say sodium because and chlorine is as not absorbed, and it is a negatively charged also. The chloride is negatively charged, so it is not get fixed up, but it is there. So this is also considered like that. So if there is a chloride concentrations are like this 4, the water is good, but beyond 20 it is or you can say beyond 12 it is not suitable at all for irrigation purposes. These are some books regarding this particularly up to this. So I hope this is of valuable and of importance to you. So this is the chloride concentrations on the quality water. So naturally, if the chlorides are less around 4, and then it is considered as an excellent water for irrigation. But if it is has been increasing with 4 to 7, maybe good water, 7 to 12 slightly unusable, and after beyond 12 or is considered to be not suitable, and beyond 20 it is 100% not suitable. So this is has to be taken care when we are discussing on these things. So then this is some few books which
So
you can
that's all
just
for
prefer.
the soil health
uh,
and quality.
so thank you.
Recommended book